Young students, we will continue with our last lecture. In the last lecture, we derived two equations, V is equal to u plus a t, S is equal to u t plus half a t square. Now, we will continue with the derivation of other two equations, v square is equal to u square plus 2 a s, s nth is equal to u plus a by 2 n minus 1. We will in the derivation of the third equation, we will be using the first two equations. From the first equation, we find the value of t in terms of the other three variables, t is equal to v minus u over a. Now, as in the third equation, v square is equal to u square plus 2 a s, time is not there, variable t is not there. So, what we do is we use the process of method of elimination of time from these two equations. For that purpose, we find the value of t from one equation and substitute this in s is equal to u t plus half a t square. U into t, t is v minus u over a plus half a v minus u over a whole square. This is the value of t in both the terms. u v, we open the bracket, u v minus u square over a plus a by 2 a square v square plus u square minus 2 u v. Here a square gets cancelled with this a. So, what we are left with is u v minus u square over a plus 1 over 2 a. We can write this as v square plus u square minus 2 u v. So, S is equal to we take 2 a as LCM. So, we have 2 u v minus 2 u square plus v square plus u square minus 2 u v. 2 u v gets cancelled. We have v square minus 2 u square and plus u square. So, we have minus u square over 2 a. So, what we get is S is equal to v square minus u square over 2 a. So, if we transpose, we can write this as 2 a s is equal to v square minus u square, or we can write this as v square minus u square is equal to 2 a s, or we can write this as v square is equal to u square plus 2 a s. So, this is the equation that is independent of t. The variables are final velocity, initial velocity, acceleration a and s. So, this is our third equation for non-uniform motion. For a body thrown up or down under gravity, A is equal to g. If u square initial velocity is upwards, then acceleration g is equal to, because it is always downwards, so it will be minus g. And if the distance travelled is h, then we can write this equation as h v square is equal to u square minus 2 g h. So, we can write from here, we can find the final velocity u square minus 2 g h under root. This is for a body that is moving in the vertical direction. The body is thrown upwards, acceleration is directed downwards. So, we take it negative. Now, say we have an object which is thrown upwards with the initial velocity u equal to 19.6 meter per second. Acceleration is equal to g downwards. So, we take its sign as minus sign, minus 9.8 meter per second square. At the highest point, v is equal to 0. So, now we substitute these values in the equation. V square is equal to u square plus 2 a s. A is g and s is h. So, v is 0, 0 square, u is 19.6 square plus 2 into minus 9.8 into h. So, from this equation we can find the value of h. H is equal to 19.6 whole square divided by 2 into 9.8. So, we have value of h comes at 19.6 meter. So, if we have the body thrown upwards with initial velocity 19.6 meter per second, acceleration is 9.8 meter per second square downwards. So, the body will reach up to a height h is equal to 19.6 meter, where it will stop for a moment and will start its downward journey. This was the third equation of motion. Now, we take the fourth equation. Fourth equation is S nth. S nth is displacement in the last second, in the last second of the journey. That is, if we were moving for n seconds, this is the distance or displacement in the nth second. We can say if we have moved for n seconds, total displacement is S n, out of which we subtract the distance travelled in the n minus 1 seconds. We can say S 1 is equal to S 1 minus S 0. This is the distance travelled by the body at rest when we had not even started our clock. So, this is 0. S 1 is S 1th is equal to 1, S 1, S second is equal to S 2 minus S 1, S third is equal to S 3 minus S 2, S fourth is equal to S 4 minus S 3, continuing like that. S nth is equal to S n minus S n minus 1. So, what we are doing is, we are taking, instead of t, we are taking the time as n. So, S n is equal to, we can write S t. S t is equal to u t plus half a t square. So, S n is equal to u n plus half a n square. S n minus 1 is equal to u n minus 1 plus half a n minus 1 whole square. So, we can write, substitute the values. S n is equal to u n plus half a n square minus u n minus u plus half a into n square plus n square minus 2 n plus 1. U n minus u n gets cancelled. So, this minus and minus, we have u plus half a n square and minus, here we have a minus half a n square. So, these two get cancelled. What we are left with is a by 2. Here we have a minus sign, minus minus plus 2 n minus plus minus 1. So, we have S nth is equal to S nth is equal to U plus A by 2 into 2n minus 1. Now, if we have distance travelled in the second is equal to 20 meter, as distance moved in the fourth second is equal to 30 meter. We are to find the distance travelled in the sixth second. We can write the formula U plus A by 2, n is equal to 2 here. So, this will be 2 into 2 minus 1. So, this is 3 A by 2. Here n is equal to 4. So, U plus A by 2 2n 2 into 4 minus 1. So, this is 8 minus 1 7 A by 2. So, from this equation we have two equations and there are two variables. We are having two equations having variables u and a. So, we can find the value of u and a. From these, if we subtract equation number 2, equation number 1 out of equation number 2, then we will have on this side 4 A by 2 is equal to 30 minus 20, 10. So, 2 A is equal to 10 or A is equal to 5 meter per second square. Now, if we substitute this value of A in this equation, what we get? 20 is equal to u plus 3 into 5 by 2. So, u is equal to 20 minus 15 by 2. So, we can write taking LCM 2, we can write this as 40 minus 15, 25 by 2. So, u is equal to 12.5 meter per second. Now, we have the values of A and u. We substitute these values in the S6th. S6 is u plus A by 2 into 6 into 2 minus 1. So, we have 11 A by 2. U is equal to 12.5 plus 11.2 into A. A is equal to 5. So, we have 12.5 or 25 by 2 25/2 plus 55/2 80/2 or 40 meter. So, S6th, the distance travelled in the 6th second, S6th is equal to 40 meter. So, with this we have derived all the 4 equations. V is equal to u plus at, S is equal to ut plus half at square, V square is equal to u square plus 2 as, S nth is equal to u plus a by 2 into 2n minus 1. Now, if we look at the equations, from these equations we can find the xt diagrams also. S is equal to x2 minus x1 as we had seen earlier. Now, if we plot a graph, here we are to plot a graph say between x and t, x and t graph, xt graph for non-uniform motion. Here t is in the second power, t square. On this side x is to the first degree, on the left side x is first degree, on the right side t is up to the second degree. So, we will have a parabolic graph. For a not equal to 0, we have a parabolic graph, we call it a parabola. Now, the same, if we use the same non-uniform motion from this equation, as we have already seen, graph between V and T, V T graph is a straight line graph. Now, if we have this straight line graph between V and T, velocity and time, we take at time t1, velocity is say v1, at time t2, velocity is v2, area under this graph, area, this area is equal to V1, area A, B, C, D is this area, because this is a, these two sides are parallel. For this kind of figure, we have area is equal to V1 plus V2 over 2 into the base T2 minus T1. Now, if we take V1 as V0 and V2 as V, we can write this as 2V naught plus V over 2 V naught plus V naught plus A T 2 minus T 1. Using this equation, V is equal to V 0 plus A T into T 2 minus T 1. So, we have V naught plus half A T 2 minus T 1 whole multiplied with T 2 minus T 1. This we can write as V naught T 2 minus T 1 plus half A T 2 minus T 1 whole square. If we take T 2 minus T 1 as T and V naught as U, so we can write this as U T plus half A T square. This is equal to S or x 2 minus x 1. So, the area this ABCD is area under velocity time graph is equal to displacement. So, if we have for a non-uniform motion, we are given a VT diagram, we can take the if we know we can find the area of the graph, we know the area is equal to the displacement. Now, in non-uniform motion we take acceleration as constant. So, acceleration time graph is parallel to the time axis. In general, we can show x t graph is a parabolic graph. V t graph is a straight line graph and acceleration time graph is a graph parallel to the time axis. With this, friends, we have completed the discussion of non-uniform motion. In this, we have discussed what is non-uniform motion, what are its equations. We have derived 4 equations. We will see later on that these 4 equations are the general equations of motion. All other uniform motion and rest are special cases of this equation, and we will in the coming lectures we will continue with the problem solving based on these equations. Thank you.